later.
Right.
Just focus on this right now and just use those different colors, okay?
Ooh, brown, pink.
So, please hear me guys, I know that some of us did not finish creating our own personal boundary line. Well, since you already did this one, you can do it on here.
Okay.
But, so we did not quite finish, so I went ahead and printed this out so that you could take the boundary lines, you can color them, and now you know which color goes with which boundary line. So, let's first do this. Let's all graph each of the points that works for both, right? So 1, 1.
On our own or on yours?
On the one I've already given you, right? So use a colored pencil for these points because the colored pencils need to go with the different boundary lines. So use just a normal pencil and use the colored pencils for the shading, right? Notice I don't have pink up here. So 1, 1, 15, 0, 2, 2, 3, 3, 0, 10, 5, 12, negative 10, 6, negative 10, negative 4, 0, 15, 10, 4, and 28. Do not do the other points I'm about to do, but I'm going to do these on my own. So make sure you have each of those pink points, each of the points that works for both, or all 4 of them. So we should have each of those points. I'm going to add some more pink in here so we can see it a little bit more clearly. Say again? So what do you notice about the difference between the pink and the orange points?
The pink is below.
It's not just below.
They're in different regions.
It would be the overlapping shading region, meaning it's not just below, it's below how many of the boundary lines?
All of them.
All of them. Because each of these boundary lines say that it should be less than or equal to, right? Does that make sense so far?
Yes, it does.
Now what I want you to see, right, so we should notice that all of my solutions are in that region, so I know where to shade. But I want to take a second, I want to look at each of them separately, okay? So grab each of your colors. So let's first look at the space constraint. Which direction should I shade in regards to the space constraint?
Down.
Down. Okay, so there, 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 and there. And I will go ahead and let you know it's going to get messy because there's 4 constraints. But you see I'm shading down. I didn't do a ton of it, just enough for me to see everywhere that I'm shading down with space. Alright, so startup boundary. Which direction am I going to shade? Down. 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 Down.
Sounds like you're talking to a dog.
And down. I do say that to my dog pretty frequently, I'm not going to lie. Alright, what about for the pampering time constraint? Down. Now notice it's going still up and to the left, so it would be down from here, but it would also even be down right here. And 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 then what about the feeding time? Down. So I'm going to go to that red line, I'm going to shade down. So remember, we only want to shade the region that what? That satisfies all the constraints. And by using colors, you can see it more easily. Where do we have all 4 constraints being satisfied? Where do we have all 4 colors? Yeah, are all 4 right here? What about up here?
No,
Here?
no,
Here?
no,
Here?
no,
Here?
no.
Here?
Yes.
Yeah, I got green, red, black, blue. Got all of them through here, right? So notice that's, again, below all the boundary lines. So I would then take it, that's where all my pink points are, and this is the region I would heavily shade to make sure it's clear, hey, these are my solutions. Now, does that get messy when you have 4 constraints?
Yes, I can't even tell.
I know, it's tough to tell, but we will get to a point where we're only mostly looking at 2 constraints at a time, okay? But the biggest thing I need you to take away from this is, how do we indicate the solutions to all the solutions to the system of inequalities? How do we indicate the solutions to the entire system of inequalities? It's where all the colors are, so it's where I heavily shaded, right? The solutions to the system needs to be the overlapping solutions, right? It's not where just one of the solutions are, it's not just where a couple of the solutions are, it's where the solutions are for every single inequality that there is. That's a note that if you're not aware of, I would write down, right? The solutions for the entire system is where we have solutions for every inequality. That's what the shaded region is. Now, people brought it up earlier. Is it possible to actually have negative 20 cats and 4 dogs? So it's not actually possible. Or if you look at the, which is hard to see, it's the which region?
Feasible.
Feasible, right? So it's not actually possible, it's not a part of the feasible region. And so that's what number 9 is all about tonight. And this is again why I gave you a graph or a sheet of paper that has a backside. This time around, what I want you to do for number 9 is just shade where the feasible region is. Identify what part of this, so notice again, shaded a whole lot of stuff, right? Are all of these points actually possible?
Yes.
No, the
Well,
negative ones are
under
not.
cat.
You can't have negative cats and dogs. So tonight I want you to wrap up number 9, shade a region in quadrant 1 that would represent all possible combinations of cats and dogs. So look at number 9, and then hopefully you already have 5.5 set number 7 and 8 done, because if so, number 9 is the only thing you have for homework. If you have not done number 7 and 8, it will be an accuracy check tomorrow. What can you do to help make sure that you have the correct inequality for number 7 and 8? Okay, you have a graph, you're trying to write the inequality, so use Desmos. Literally, you can create a few different inequalities and get to a point where you're like, hey, that is the correct shaded region, that's the correct boundary line. So use Desmos for that. And please get it done. Also, just as a quick heads up, we will be having an understanding check on Thursday. It's going to cover mostly what we have done in 5.4, 5.5, and 5.6.